of geometric sequence are the following: 2, 4, 8, 16. And you can tell me what the common feature of these two sequences is. What do they have in common? And what is the pattern for the first and second one? Okay, so the first one does definitely double, right? Times by 2 times 2. Second one, you have to divide by, or times by, actually, let's keep it with times. Times by, not half, but negative half, right? Okay. So if you have to say there's a common feature between the two, is that you get the next number by multiplying by a number instead of adding like arithmetic. Okay, that's what it defines to be a geometric sequence. Okay. So we again declare this first term, right? These two guys, that's the first term. Okay. We usually denote it with the letter A, and these ones at the bottom, right? We call that a common ratio. Okay, we usually use the letter R for that. Okay, you multiply by R. Okay. I mean, how would you numerically get the number 2? You do this, right? This number divide by the previous number, right? Same here. It's a little bit more complicated, but 3 over 2 divide by negative 3 is the same thing as times by negative 1 over 3. And you can see that you're going to get negative half. Okay. So let's talk about the general formula first. Okay. So if the first term is A, the next term is going to be AR. The next term is going to be AR squared, right? If you multiply by R, AR cubed, and so on. So tell me, what would T32 look like in this case? If this is T1, T2, T3, and T4. The pattern is simple, right? See this number on the top here? See this number on top of the R? It's exactly 1 less. Right, you subtract 1. So from that we can say it's AR to the power of 31. So what is Tn going to be then? The general term. AR n minus 1. Okay, that's a general term. Okay, so I want you to generate the general term for A and B, please. Try that now. Okay, so this one is going to be, if you follow the formula, it's 2 times 2 to the power of n minus 1, but these two exponents, same base of 2, you can combine to be 2 to the power of n. And you can see that this is actually the power of 2, right? Okay, B. What do you think, Jay?
Negative 3 times negative half to the power of n minus 1.
Yes, this is a little bit more complicated, right? So this is, you can write it this way, negative 3. You can write that as this, negative 1 to the power of n minus 1 and half to the power of n minus 1. So you separate the complicated negative. So I mean, it doesn't simplify that much. Negative 3, negative 1, n minus 1. Perhaps you can change that into the power of 2, and then you know half is the same thing as 2 to the power of negative 1.
Yes.
So you can change that to 1 minus n. It doesn't simplify that much though. For something like this, yeah, most teachers will be fine with that. Some teachers might ask you to do this. Because this kind of more clearly communicates exactly which numbers will be negative. In fact, actually, let me make it even, because of the fact that the plus and minus alternates, right? Let me actually simplify one more time. See this minus 3? I'm going to put that as 3, and that minus in front, I'm going to change to minus 1 to the power of n minus 1. If you multiply those two, you actually get minus 1 to the power of n, right? Agreed?
Yeah.
Now this tells you exactly which terms is going to be negative. if it's all number up here, it's going to be negative, right? So minus 1 to the power of odd, you know, is going to be negative. Which means all the odd terms of this sequence will be negative. Look, first term, third term, they're all negative, right? So actually this is, I think this is the best form right here.